This video works on depreciation problems, which are an application of our exponential problems. So this will be an exponential decay type of problem. So our objective is to be able to solve depreciation problems. So first of all, depreciation is where the value goes down. In this case, we're going to refer to that, we're going to use this as an application of exponential decay. Now, the formula for this will look very much like the interest rate problems we did, only the key here is that we're going to subtract the rate. When we're looking at the rate of depreciation, that's going to lower the amount, so we're going to subtract the rate. So our formula is going to be A equal to the initial amount, which we're going to call P again, like it would be principal, times 1 minus the rate to the T power. So this would be if we're talking about a depreciation annually. We're not going to break it down like quarterly or semi-annually, but we're going to subtract the rate. So this is our base of the problem. If we take 100%, which is the 1, and subtract the rate, say we subtract 20%, that would be down 100% minus 20% would be 80%, which we would list as a base of 0.8. So let's take a look at a couple examples using this formula. First of all, we've got this problem where we start with $40,000, so our amount is going to equal $40,000 times 1 minus 5% is 0.05. So you put the rate, remember, as a decimal to the T power. So we're going to make that equal to $40,000 times 1 minus 0.05 is 0.95. So our base, notice, is less than 100%, so the value is going to go down as an exponential decay problem. So what we want to know is what is the amount when we take $40,000 and we put times 0.95 to the 14th power. So let's go ahead and calculate that. So when we do this, we're going to take 40,000 times 0.95 raised to the 14th power. And we get an answer of $19,507. If we were to round to the nearest dollar, 19,507. So that's how much the car would depreciate in the 14 years to give us the amount it is worth 14 years into the ownership. Let's try another one here. A snowblower is purchased for $1,235 and depreciates at 12% a year. How much is it worth in 5 years? So again, we're going to take A equal to the initial amount, $1,235, times 1 minus, it's going to depreciate 12%, so it's going to be 0.12, all to the T power. So we're going to get 1,235. 1 minus 0.2 is 0.88. 88% of its value every year is how much it's worth, as it loses 12% every year. Now when we go ahead and calculate what this is equal to, we're going to put in the amount for our number of years. It's going to be in 5 years. Let's go ahead and calculate what that would be. So 1,235 times 0.88, excuse me, 0.88 raised to the 5th power, and we get about $652. So rounded to the nearest dollar, $652. So to figure out depreciation is an application of exponential decay. You're going to have to make sure you substitute in the formula, instead of having our 1 plus where we do interest rate problems, we're going to subtract the rate each time. And when you do that, recognize that your problem will go down in value by that rate every year until we get our final amount of an exponential decay problem.